Hi, welcome to Real Learning Center. This is the second video of our course on motion. So as we discussed in the last class, how motion is relative, where we said that you just can't say something is moving or something is at rest without actually referring to the frame of reference with respect to what it is moving. So now we will go a little deeper into understanding motion. When something moves, what happens? With all the understanding that we always talk about with respect to some reference. So we will move forward. So now the question that we are going to ask is, we are going to introduce two words called as distance and displacement. Now what is the meaning of distance? What is the meaning of displacement? We have actually dealt with these things, at least the word distance in the real world, in the normal English language that we speak. So is it same as that or is it slightly different? We'll see all that. Okay. So let's start with a very simple question. Okay. So now, what is the traveling distance from Mumbai to Bangalore or from Bangalore to Mumbai? What is the distance, traveling distance from Bangalore to Mumbai? That is the question. So what do? You Google it up and find out what is the traveling distance, and you figure out that there are actually not one single path. There are multiple paths to go there. Okay? And distance depends on what path do you choose. So it depends on the path. So on what path you are choosing, it depends on that. Now in one path, and you are going on road, let's say you drive or you take a bus, on one path it's about 980 kilometers. 980 kilometers. In another path, if you take a slight diversion and go, it is 1162 kilometers. So whenever you talk about traveling distance, so distance in terms of traveling, so you always think about associating with respect to the road you take, the path you take. If you take actually train services, see, okay, then you can clearly see that by train it is 1030 kilometers. It is even different. In fact, by air if you go, it's even nearer. It's like 980 kilometers. So one cannot actually tell what is the distance that is traveled without actually telling, without actually specifying the path of travel. So that is what we understood from the distance. Now, however, if somebody asks the question, how much is the displacement when you go from Bangalore to Mumbai? Nobody will ask this question. This is not a normal English question. This is a physics question. Okay. So what is the displacement when you are going from Bangalore to Mumbai? In fact, if somebody asks a question, what is the straight line distance between Bangalore and Mumbai? Okay. It is what one can ask. Okay. Those two are somewhat similar. Okay. It is the straight line distance, or we can say the shortest distance. If you draw a straight line and measure on the map and convert it using scale, you will know that what is the distance, what is the displacement. Okay. So displacement is nothing but the shortest distance, which is 836 kilometers in this case. So however, you need to understand one very important thing. When you say displacement, it actually means something is displaced from one place to the other place. There has to be some movement. Something has to move. So then only we talk about displacement. Okay. It's not about what is the distance between Bangalore and Mysore. So that is a very different question. Okay. Displacement is actually about when something actually moves. And even in the word distance, we don't use the distance in this English sense of what is the distance between these two. Whenever we use distance in physics, we use in a sense of traveling distance on a given path. That is our distance. Okay. Displacement is again when some traveling happens, when some motion happens. Okay, please understand that. So distance and displacement, if you see, the definition is very clean. Okay, when an object moves from one place to another, say from A to B, only when it moves, displacement will happen. Okay, then distance is the length of the actual path it has traveled from A to B. Whereas displacement is the shortest distance between A and B. So is it confusing? What is meant by length of the actual path and length of the shortest distance? I think it is understandable if you give a slight consideration and a careful attention to an example that I am going to show. Okay. So let's consider this scenario where there is one ant here standing at a point called A. Okay. Now let's say this ant starts moving to the point B. Okay. Now if you ask me a question, what is the distance traveled by the ant? And what is the displacement of the ant? So what is the answer to that? Let's say this distance displacement is 2 meters from here to here. And in this case the distance also is 2 meters because it is a straight line. So distance and displacement happen to be same in this case. Whereas if you take for example another case here where ant decides not to follow a straight line path and actually goes through a different path like this. So when not flying, it goes through another path. Okay. When ant goes through another path, then what is distance? What is displacement? So if you look at this, displacement is still 2 meters. Ant was here, ant is here. So displacement is still 2 meters because the shortest distance between point A and B is 2 meters. Whereas the distance traveled is definitely more than 2 meters. It went in that way. So you can actually take a tape and measure that path and you will definitely find it to be more than 2 meters. So in this case, distance is different from displacement. So let us take another simple scenario. Okay, let's take a chessboard, okay, with a queen standing in the middle. Okay. Now, I want to make one move and ask you what is the distance traveled and what is the displacement. Think about it and answer. Anyway, I will answer afterwards, but you can pause and think, okay, once I ask the question. So distance traveled, so how do we measure this? We are not using a centimeter or a meter scale. We are just saying that one square, if it moves, it is distance 1. Okay, 1 square is called 1 unit. Okay, that is the measurement of the displacement. So let us make this queen move now. Okay, queen moves like this. Wow, it moved down and came back in its 2 moves. Okay, now what is the distance traveled in terms of the number of squares? You can clearly see. So you can pause it here and think. So the answer is, okay, it went 3 down and then back 2 up. So total distance traveled is actually 5. 3 plus 2. Whereas the displacement is how much? It was here in the middle, that cross area, and then went only down 1. So displacement is just 1. So distance is how much? 5. Displacement is 1. So let us take another scenario. What happened here? When it moved here from that cross point, you see. Okay. So it just moved 3 squares. That's all. So here distance traveled is 3 and displacement is also 3. We shall take another scenario. Okay. So now in this scenario, it goes like this. See, it went there 3 steps and comes back 3 steps. So in such scenario, what is the distance traveled and what is the displacement? Think and tell. Yes, distance traveled is 3 plus 3, whereas the displacement is 0. Initial position is the same as the final position. So displacement is 0 and distance traveled is 6. So let's take lastly one more example. See, it went up like this 2 and came back down by 3. Now what do you say as distance traveled? I think you can say 2 plus 3, 5. So what is the displacement? So displacement in this case is slightly defined, because I am going to call displacement as minus 1. Why? You know, if it had gone up and came back by 1, I would have called displacement 1. So it started in some direction and came back, but it's still in the same direction. Whereas in the second scenario, in the real scenario, what we showed, it went up and came down. So the displacement is in the opposite direction of where it started. So you see, this peculiarly we started talking about in which direction, that kind of a word. Okay, and that gives us some hint on that basically property of what is displacement. Okay, displacement is somewhat a new kind of a mathematical or a physical entity. Okay, we will see what it is. Okay, displacement seems to have a direction. So because you see this ant, for example, when it is going from left to right here, A to B when it went, okay, we will say the displacement is simply this arrow. Okay, we specify an arrow. An arrow is going from left to right. The length of the arrow actually is telling us the amount of displacement, and the arrowhead is telling us the direction of displacement. On the other hand, when it comes back, let's say it turns back and wants to come. So when it comes back from B to A, then our displacement is actually from right to left. Maybe how much it has displaced is same, actually, but the direction is different. Hence, displacement from A to B is different from displacement from B to A. So A to B is not same as B to A in terms of displacement, because direction actually matters in displacement. So such a thing where direction matters is called as a vector. Okay, it's a new word. So some physical quantities like that, where direction matters, such quantities we call them as vectors. Okay, so the arrow length shows basically how much displacement, and the arrow head shows in which direction. So we use some slightly different words in when you want to mathematically understand this. We call how much as magnitude, and we call direction as direction only, no other word. Okay. So whenever we say magnitude, it simply means in your mind you think of as how much, and direction is the arrowhead. So if something has both these, things that have both magnitude and direction, any physical quantity which has both magnitude and direction is called as a vector. Okay. So our displacement actually is a vector quantity. Okay. So displacement, whenever somebody says what kind of a physical quantity it is a vector quantity, because it has direction also along with how much. Whereas distance traveled is a scalar quantity. Okay. So what is this scalar quantity? Today I traveled a distance of 30 kilometers for going to school and coming back. To go and come back, I traveled 30 kilometers, if I say. So we don't specify actually in which direction. So we just say magnitude of the distance is 30 kilometers. We don't specify any direction here. We went and came back. We kept changing the direction. But totally, this is the distance traveled. So it's a scalar quantity. So anything which only talks about the magnitude or how much, such a quantity is called as a scalar quantity. It has some numbers, some units, all that, but it doesn't have any direction. You don't have an arrow for them. Okay. Hence distance is actually a scalar quantity. Can you give another example of a scalar quantity? Think about it. Let's say time. It is 2 o'clock now. So will you ask me in which direction? No. So time is a scalar quantity. So if you ask me, for example, what is the temperature? Temperature is 80 degree. 80 degree, that's a Fahrenheit. So will you ask me in which direction? No. So whenever you don't ask this question in which direction, that means it is a scalar quantity. So there are some examples. So these are some examples of the scalar quantities. So let's understand the distance traveled and the displacement a little better, in much more, slightly more mathematically here, quantitatively. Quite simple though. Okay, just look at the way we calculate that. Okay. So let's say there is a tennis ball here, standing here, which goes to the right for 4 meters and then to the up for 3 meters. So I will ask a question. Calculate the distance traveled, calculate the displacement. Quite a straightforward question. Think about it. So distance traveled, straightforward, is 4 meters plus 3 meters. Is 7 meters. You know, 4 meters you traveled, 3 meters you traveled. So total 7 meters. What about the displacement? How do you calculate? So whenever we talk about displacement, it is all about the shortest distance between initial point and the final point. Where this initial point and the final point, what is the distance? Shortest distance. You draw a line actually from initial point to final point with an arrow pointing towards the final point. That is the vector. That is the displacement vector. And you take a scale and measure it. Draw a 4 meter line. Don't draw a 4 meter line. You can use a scale and draw, let us say, 4 centimeter line and a 3 centimeter line, and then join. So you measure that. And when I happened to measure like that, it was showing me 5 meters. So the shortest distance is 5 meters. That is called the displacement. In this case, the displacement is 5 meters. Okay. What about this? The next question. Calculate the distance traveled and displacement in this case. So what is happening is there is a semicircular path, okay, with a radius of 7 meters, and a ball actually is going like this. So what is the distance traveled and what is the displacement? So distance traveled, of course, is the whole path. So length of the path, how much is that? So if you know the circumference of a circle is pi into diameter. Half the circumference of the circle is pi into diameter divided by 2, or pi into radius. So pi into radius is 22 by 7 into radius, which is nothing but 22 by 7 into 2. Hence, we can say distance traveled is 22 meters. Displacement is just 14, twice the displacement is the actual distance, shortest distance between initial point here and the final point there. So that is just twice the radius, and that is nothing but 14 meters. So this is how you can calculate distance and displacement. Once you get this right, then we can move on to understand the speed and velocity, and finally acceleration. Okay, all the best.